So at some point in the sculpting process here, you're going to want to get an organized mesh. Dynamesh works really well for like 90% of the sculpting process. But on a unified mesh, the highest you're really going to get in Dynamesh resolution is somewhere around 4 million. And if you're going for things like tight detail, pores, skin wrinkles, that kind of a thing, it's not going to give you the best results. For this, you want to switch to a subdivision mesh. And ZBrush's automated system for creating subdivision meshes is called ZRemesher. ZRemesher is located in the Tool menu, in the Geometry palette. Down here, there's a sub-palette called ZRemesher. Now, using ZRemesher can be as easy as simply clicking on this ZRemesher button here. But if you need more control over the kind of topology that you get from ZRemesher, you can leverage these other features that are located in the palette. ZRemesher is going to create a much more organized topology than what Dynamesh does. It's going to create clean edge flows and edge loops, and it's very subdivision friendly. So it'll allow you to get into resolutions into the hundreds of millions if you need that. Having a clean subdivision mesh is also necessary if you're going to be UVing your model to create things like texture maps or to use things like surface noise and some of the other features that leverage UV mapping in ZBrush. It's also important if you're going to be exporting your model into a different software package like 3D Studio Max or Maya. If you want to see more information about the different kinds of topology in ZBrush and their strengths and weaknesses, check out the previous chapter on topology. So let's just do a simple ZRemesher process to remesh this goblin head here. The first thing that you're going to want to do is, if your model is symmetrical and you want a symmetrical remesh, you have to make sure that you have symmetry on for your sculpting brushes when you click on this ZRemesher button here. ZRemesher will look at whether or not you have symmetry on, and if you do, it will make your mesh symmetrical on both sides. Now, because what ZRemesher is going to be doing is creating a base mesh for us to do subdivisions on, it's going to be creating a mesh that is much lower in resolution than our current Dynamesh here. Because of that, it will initially lose all of the detail that we have currently on this mesh. So we need a way to get that detail back. There's a couple of ways we can do that. The first way is we can simply create a duplicate of our mesh to project back onto our new ZRemesh topology as we create higher levels of subdivision. But another thing that we can do if we don't want to have an extra mesh in our subtools is we can come up to our history bar and store a history state. This will store the projection detail of our model into memory, and we can project back from that history as we create higher levels of subdivision. To store a history state, all you have to do is hold Control and tap on the current history marker. And you'll see that we get this white bar inside of that history marker now. This will allow us to project back the information from this history state onto our new topology. Now that we've got that for this first simple demo, I'm simply going to go down to Geometry and click on the ZRemesher button here. When I do that, it's going to run the ZRemesher process. It may take a few minutes, so I'll come back as soon as this is finished. So actually that only took about 20 seconds. Let's turn on our polyframes and take a look at the new topology that ZRemesher has created for us. ZRemesher has done its best on its own to create good edge flow. It's attempted to make some edge loops here around the eyes and kind of an interesting one around the nose here. It didn't do quite as good of a job on figuring out that these were the lips, and around the ears as well, it could have done a better job. But this is a pretty good first pass without giving ZRemesher anything really to work with. There's going to be a few areas where your topology might be a little crunched up, so you can come in here and smooth out those areas. Once you're done going through your entire model and looking for problems, which should always be your first step after running a ZRemesher process, we're ready to project our detail back onto our model. Now, if I turn off my polyframes here, you can see that right now there's almost none of the smaller detail left that had been sculpted in Dynamesh. To get this back, we're going to project the history state that we have here back onto our new topology. To do that, we're going to go to the Subtool menu, to the Project tab here. And under this tab, we have the Project All button and the Project History button. If instead of creating a stored history state, I had created a duplicate of this mesh, I would be using the Project All button to project the detail back onto our model. If you have other subtools in your scene besides the original Dynamesh model and the new topology that was created by ZRemesher, you're going to want to turn the visibility off on those subtools so that the Project All doesn't attempt to project those subtools as well. In this case, though, we have a stored history state, and this will only project from the saved history state that we already have stored from our Dynamesh. So then the process of getting our detail transferred onto our ZRemeshed model is pretty straightforward. I'm going to come over and click on the Project History state. In this case, it's going to say that one or more of the subtools that I have visible in my scene right now has polypaint information, and do I want to project that polypaint when I'm projecting my history? In this case, I'm going to say no, because the polypaint icons that are on here are for different subtools, and it's just white polypaint anyway, so there isn't really any information there yet. In fact, it's probably a good idea if I simply turn those off. Now, if I look back at when my model was still in Dynamesh mode, you can see that my active points were 1.1 million, and when we re-Dynameshed, this dropped it all the way down to 18,000. So the first level of projection is not going to get very much of the detail back. To do that, I'm going to need several more levels of subdivision. So let's go ahead and hit Control-D to add a level of subdivision here, and then click on Project History again. We're still getting this dialog box here saying that there's polypaint data, even though these paint icons are off. I'm going to go ahead and click No again, and you can see that it projected some more of that detail into my ZRemesh topology. Let's Control-D to create another subdivision level here. We're up to about 300,000. I'm going to turn off this color button here under the project palette. That's going to take away that dialog box because this button determines whether or not color is going to be projected. Let's go ahead and click Project History. It takes a little bit longer as we go up in subdivision levels for that projection to happen, by the way. So we got a little bit tighter detail in here again. Let's go up one more subdivision level, Control-D, and click on Project History one more time. It'll take a little bit longer to project those details on this higher resolution mesh. And now we're looking at a resolution that is about the same as our Dynamesh was originally. If I go back to the history state where our model was a Dynamesh, and we look at the detail that we have in the Dynamesh model, and then I go back to my ZRemesher version, we see that they're basically identical now. The advantages for me, though, are that now that I've got a subdivision mesh, I can continue to make higher levels of subdivision. Now I'm over 4 million. I can divide again, and now we're up over 18 million. And ZBrush will actually be able to handle this very easily. So sometimes clicking on the ZRemesher button with its default settings will be all that you need. Other times, you're going to need to be able to exert more control over the topology that ZRemesher gives you. That's what these controls are here in the palette. In order to see the results that we get from these other controls, I'm first going to turn on my frames here and drop down my subdivisions to its base level. Now let's go ahead and bring this over into the corner, and I'm going to change my material to skin shade for. And I'm just going to go ahead and click Shift S to make a snapshot of that on my canvas. And then we'll recenter my model. And now I'm going to go back to the original Dynamesh topology that we had and try some of these other controls to see if we can get a better result. One of the first things you might notice in the ZRemesher palette here is this Legacy 2018 button here. ZRemesher updated its algorithms in 2019, but they created this legacy button in case the older algorithm works better for your individual model. The new algorithm is really useful for things that have sharper edges, hard surfaces, and it adds some features which are not available if we have this legacy button turned on. You see that we lose the ability to smooth groups, keep creases, and detect edges. All of these are only available if we're using the current ZRemesher algorithm. But it can still be a good idea sometimes to see what kind of a result the Legacy 2018 algorithm will give you. Let's turn that on and go ahead and click on ZRemesher and see what the results are. We'll let this run and come back when it's finished. So now that it's done, we can look at the results that we've gotten here. You can see that there are some differences in the topology that was created with the legacy algorithm. It's a little bit different, especially in the mouth area and nose area here, but it's a little bit worse in the eye area. So I'm going to undo that and turn off the legacy button here. Now there's actually another algorithm that's hidden inside here, and that algorithm will change the way the symmetry looks. If we hold Alt when we click on the ZRemesher button, we'll get an alternate symmetry to our mesh. Now that that's complete, you can see that the result is quite a bit different than our default ZRemesher, especially around the middle areas where the nose is. We get a different look to the topology here. This actually is probably better in this case than the default settings are for me. There's a little bit of problems in the size of the polys that are being created in these little areas around the nose. So let's take a look at how to adjust the target poly count that ZBrush is going to use for our base topology. The main control for our resolution is this target poly count here. The number that you see here is in the thousands. So right now, where it's set to 5, that's telling ZBrush that my target poly count should be 5,000 polys when I run ZRemesher. The Adapt button will allow ZBrush to simply use this number as a rough estimate when running ZRemesher. The resolution you get might be quite a bit higher than just 5,000 polys. If I turn this Adapt button off, then when I run ZRemesher, it's going to try to get as close to 5,000 polys as it can. In most situations, though, I leave the Adapt button on. The half, same, and double buttons here will disable the poly count slider and instead use the current resolution of your model to determine the target poly count. If I have it on half, and my model is currently at 10,000 points, it's going to shoot for half of that when I ZRemesh. If I have it on double, now it's going to shoot for something closer to 20,000 polys. These buttons are mostly useful if I've already run ZRemesher once and I want to try to get a different topology than what ZRemesher gave me the first time. I could set this to same and then run ZRemesher again and get a different result. A lot of times, ZRemesher will work better on a previously ZRemeshed model than it will on a very high-resolution Dynamesh model where ZRemesher can sometimes have some difficulty translating to a ZRemesh topology. Let's bring this back to the Dynamesh topology here. This adaptive size slider is going to allow ZRemesher to adjust the size and shape of the polys that ZRemesher creates. If we have this set down to 0, then ZRemesher is going to try to keep the polys roughly the same size And it's also going to try to keep the shape of the polys as close to square as it can get. At 50, it's going to allow a certain amount of variation in the size and shape, particularly in areas of your model where the form is more complex. At 100, it's going to adapt that size even more. Normally, this is usually best kept at about 50, though there are some instances where you may set it to 0, especially if you're doing some hard surface box modeling with ZModeler. Let's just run this once at 0 so that you can see the kind of topology that you get when you change the adaptive size slider. So with adaptive size set to 0, you can see that the topology that ZRemesher creates has a more even distribution and size relationship than when it's at its default settings. However, that's resulted in some issues in the resulting mesh in several areas, since ZBrush wasn't able to adapt the size of the polys to overcome the more complex form areas of the mesh. With adaptive size set to 100, ZRemesher changes the size and shape of the polys even more than it does when it's set at its default of 50. This allows it to capture a lot more detail in the complex areas of the model, but it also results in a more uneven topology than what we get when we have it set to its defaults. Most of the time, I find 50 to be the best setting for most instances. Now this curve strength slider here requires the use of a special brush called the ZRemesher Guides brush. I'll hit B and then Z to isolate to our brushes that begin with Z, and here you see the ZRemesher Guides brush. It's got a shortcut key of R, so I'll click on that. And what the ZRemesher Guides brush is going to do is it's going to put down a curve line that ZRemesher can use as a guide for placing the edge flow and edge loops. So I'm going to go ahead and put a curve around this eye orbit here. So I'll come in, click, and drag. And we see that we get this sort of dashed curve line in here. What this curve line is made up of are these dashed sections here, and this is the resolution of the curve brush. This is determined by the size of your brush. Right now, this feels a little too large to me, so what I'm going to do is hold Alt and then click and drag through the curve to delete it. Now I'm going to make my brush size a little bit smaller and do the same thing. Let's come up here and draw a line and connect it up here for the eye orbit. And that looks pretty good. Then let's also come down and do one around the nasal area, around these nostrils here. Now you see that they kind of snap together at this point, and I don't want that. What I want is two separate curves here. There's a couple of ways we can stop this from snapping at the center here. The first one is to go to the stroke menu, to the curve modifiers, and change this curve snap distance here. I've already dropped it a little bit, but I'm just going to bring it down to 1. And then I'll click and drag around here. Now this still might not be enough, and you see that it's not enough. And the reason for that is the size of my brush is still a little too large to stop it from snapping there. So I'll undo back, make my brush size quite a bit smaller, maybe something like that, and then click and drag. And now we've got marks around the nostrils. Let's also put one around the mouth. I'm going to make the brush size just a little bit bigger. And then let's come in here and click and drag around the mouth. Now I could put in more guides than this, but in general, the ZRemesher Guides brush works best if you don't put too many guides down. You don't want to cover your model with guides everywhere. ZRemesher has a difficult time working with so many guides. So I'm just going to use this for now. Now that I've got this and we have symmetry on, which is why you see that there's this kind of faded one on the right side here, I'm going to go ahead and click on ZRemesher, and it's going to use these guides to help place the edge loops. Right now, we're setting the curve strength to 50, meaning it's giving it about a 50% weighting when it's determining the topology. let's go ahead and turn on our frames. And you can see that it's done a fairly decent job creating edge loop around the nose area. Maybe not quite as good, but fairly decent around the eye orbit. We could probably use a curve around the actual eyelids as well. And around the mouth, we finally have some edge looping happening in that area. So it's done a fairly decent job, but not perfect. We can change that curve strength resolution, so I can undo back, and we get our curves back in this case. And if I increase this, we may get a better effect. A lot of times, though, I notice there isn't a huge difference between 50 and 100. At 100, we're going to get a different result entirely, and I'll show you that after this, though I am going to recommend you don't really ever use the 100. So at 85, you see it really didn't give us a different result at all. Maybe it did a little bit better in the eyelids. But other than that, it's pretty much the same as when our curve strength was set to 50. I'm going to go ahead and raise this up to 100 though. And when you're at 100%, it's usually going to have a problem because it's going to try to perfectly stick to these curves and it'll put an edge loop exactly where these curves are. So here you see that we've gotten a curve loop exactly around those areas, but we get some problems with our topology when we do that. We get these little white polygroups, which oftentimes mean that there's a bit of an issue in this area. And you'll see that we also ended up with some kind of messy topology in some of these places too, because it was forcing that edge loop into our mesh. So generally speaking, I don't like to use it at 100, although for very hard-edged models, this can sometimes be a little useful. I'm going to undo back here. And if you want to get rid of all of your curves, as long as you've got the ZRemesher guides brush on, all you have to do is tap on your mesh and it will delete those guides. If you have a different brush on, let's say I have standard brush, and you tap on your mesh, it's not going to do anything because you don't have these guides active currently. So what you can do is either switch back to the ZRemesher guides brush, or you can go up to the stroke menu to curve functions, and you can click on this delete. And that'll do the same function as tapping on your mesh with the ZRemesher guides brush active. Generally, a better way to control the topology that ZRemesher gives you is to use polygroups. Using polygroups generally gives a better result than the ZRemesher guides does. So let's go ahead and create some polygroups for this head here. I'm going to start off by just making the whole thing one polygroup, and let's turn off the line so that we just see the polygroup color. Now I'm going to come in and use the select lasso, and let's kind of get a face mask or a little eye mask around the eye area here. Let's make that a little bit deeper at the bottom so that the eyes are kind of in the middle, and also try to make that pretty even as well. You want to try to get this as good as you can. I'm going to hit Control W so that we have one polygroup in here, and now let's go ahead and let's create another one around the eyes themselves. Now with Mask Lasso, you're going to notice that it's going to create a mask all the way through your mesh. So I'm going to have to come in here and hold Alt to get rid of that mask that happened on the back of the head. And let's come in here, and I'm going to have to, again, go to the back of the head after I adjust this here. So let's just finish making the adjustments first, and then we'll clean up the back. You can also just use the mask pen brush in here if that's a little easier for you, but this works pretty good. All right, so let's go ahead and clean up the rest of this. So I'm just going to hold Control and then Alt and just drag it around there so that we don't have any of those extraneous masks in that area. Let's go ahead and hit Control W to create another polygroup. It's a little hard to see that one, so I'm going to isolate it and hit Control W again so that we get a different color there. Let's do one around the nose. something like that. Again, clean up the back so that we don't have that happening back there as well. Control W, and again we get another green poly group, so let's go ahead and change that. Now this one looks just like that one, like the rest of the head, so I'm going to just make it so that the colors are a little bit easier to see here. So now I've got a couple poly groups there. Let's also go ahead and do one around the eyes here. So I'm going to come in around the eyelids. Okay, so that should be pretty good. Let's get rid of the effect on the back. And once more, hit Control W so that we have a poly group around there. Okay, I've done a little bit of cleanup around that eye there, so let's zoom back. Now for ZRemesher to use your poly groups in determining your edge flow, you want to turn on this Keep Groups button right here. And normally, the first time that you run it, you want this Smooth Groups to be set to 1. If you remesh again after doing this once with Smooth Groups set to 1, you can then drop it down to 0. And since it's already run it with Smooth Groups set to 1, it usually won't have any problem after that. So we're going to keep this at 1 here. Now another thing that I want to do is I'm going to store a history state up here to store the projection detail of our mesh. And then we're going to go down to deformation, and we're going to do a polish by groups to get rid of this pixely edge to our poly group, because ZRemesher sometimes has a difficult time when the edge between poly groups is not very clean. So I'm going to go ahead and grab this polish by groups and just drag it all the way over, and it's going to do its best to create a cleaner edge here. Maybe we'll run that a couple of times to see if we can get an even better edge. That's pretty good. And now what we'll do is go to Geometry. We have Keep Groups on. I'm going to turn my lines back on for my polyframe so that we can see that. And then I'm going to go ahead and click ZRemesher. And now you can see that ZRemesher has done a pretty solid job of creating loops wherever those poly groups were. We have a little bit of an issue right here in the eye, however, so I'm going to undo that. And let's change our target poly count here to 15 and try it one more time. Okay, it looks like increasing our target poly count did a much better job of creating a nice clean edge loop around the eyelids here. Overall, it's done a pretty decent job. There's some areas that could be a little bit cleaner, but this is pretty good, especially for a non-human face. From here, all we would do is project our detail back from our history, and then subdivide up and continue until we get all of the detail from our Dynamesh topology onto our new ZRemesh topology. Now, unlike ZRemesher guides, using polygroups allows you to get very specific on where you want your edge flow to go. So here I've done polygroups over this generic male head here, and you can see that ZRemesher used those polygroups to create very exacting edge flow for this model. Now another thing that you can do with ZRemesher is you can change the density of areas in your mesh by using polypaint. I'll go down to our ZRemesher palette again, and down here we have this Use Polypaint button here. If I turn this on, we see that we get this color density slider, and currently it's set to 2, which if we look at our color, it's kind of a pinkish color. If I bring this all the way up to 4, you'll see that it gets more and more saturated until it's very bright red. If I go to 1, it's going to be white. So 1 is just a neutral density indicator. If I go below 1, you're going to see that we start to go into the cyan ranges until we get down to 0.25, which is just fully saturated cyan. So let's say we want more topology in the eye areas. So let's go ahead and bring this up to 3 and hit enter. And now what I'm going to do is switch to a paintbrush. And I can do this one of two ways. I can either use my polygroups, which is generally going to be a better way to do it, or I can just paint on my model. I can just come in here and paint this. And if I turn off my frames, you can just see the color being painted directly on there. So if I wanted to paint my lips and the eyes, I could just come in with the paintbrush and paint those areas in. Or what I could do, if we undo that back, is I could simply isolate the areas that I want and then flip the visibility and then go to Color, Fill Object. And now when I bring it back, you see that we get that color filled exactly in those areas. Let's go ahead and also grab the ears here and fill these as well. All right, so now that we have this color filled in here, when we ZRemesh this, it's going to look at the color that we've put down in different areas of our mesh and use that to determine the density of the mesh in those locations. So let's go ahead and click on ZRemesher. Let's bring our color back to white here and turn on our frames. And you can see here that around the eyes and lips, our resolution is much denser than it is in the areas that were left white. Sometimes it creates geometry that you're going to need to clean up, but if you need the extra mesh density in certain areas, this is a good way to go. So now let's take a look at this Detect Edges button and how ZRemesher uses it to help us retopologize hard surface items like this simple mechanical form that I created using Live Boolean. First, let's just click on the ZRemesher button to see what we get with our default settings. And I'm going to change this material back to startup so that we can see the shadows and stuff a little bit easier. You can see that while it retopologized our model, it didn't do a good job of retaining the sharp edges that our initial form had. Let's undo that, and let's try just increasing our target poly count from 5 up to 50. And let's go ahead and click on ZRemesher again. And you can see that even with a much denser mesh, it still hasn't done a real great job of keeping nice sharp edges at those corners. If we turn on Detect Edges, and I'm just going to bring my target poly count back down to 5, ZBrush is going to look for sharp transitions, and it's going to put a poly group around those areas, and it's also going to put what's called a crease in those areas to keep the edge sharp even if we subdivide with smooth subdivisions on. So let's go ahead and click on ZRemesher with Detect Edges on. And now you can see that around those edges, ZBrush has made a poly group. There's also this dotted line that's happening at those edges, and that's that crease marker. If I subdivide up, areas that have creases will retain that sharp edge, while areas that don't have creases, you can see here, are rounding out. I'll undo back, and you can see that the area here that didn't have a crease, as we subdivide up, is getting a round edge to it. So what if I want to change the resolution in one area of my model? I can use freeze border or freeze groups to do that. They essentially do the same thing. In fact, you can only have one on at a time. What these buttons will do is they will freeze the edge either of an open border with freeze border or of the edge between two poly groups, which is what freeze groups does. They're pretty finicky controls, and in general, I don't use them because the results can tend to be kind of messy. But let's show you real quick here what this does with freeze border. So let's say I want to increase the resolution of the forearm area of this bodysuit. What I can do is I can hold Control and Shift and isolate just that forearm area so that the rest of the model is hidden. Then with freeze border on, ZRemesher will consider the edge between the visible area and the hidden area to be an open border. Then what I can do is change my target poly count, or I can click on half, same, or double. In this case, I'll just click back on double. And then when I click on ZRemesher, it will freeze the topology at those borders, and you see we have more topology now in that forearm area than we did previously. However, if I rotate around to the back, you'll see that we do have a little bit of an issue in the mesh at these areas. It's not terrible, but it's something to be aware of, that it can be a pretty finicky feature. So most of the time, what I would rather do is use the poly paint to control the color density instead of using these buttons here. Okay, that's going to finish our chapter on ZRemesher. ZRemesher is one of many different ways to do topology inside of ZBrush. We'll be covering some of the others in later chapters.